Section 8.4 continues with hypothesis testing, but it switches from proportions to means, specifically mean problems where we know the standard deviation of the population. In example 1, we're looking at the starting salaries of actuarial graduates, and it said that the average starting salary is $40,000. A college placement officer feels that this number is too low, so she surveys 36 actuarial graduates and finds their average starting salary to be $41,000. Is this evidence in support of her claim that this $40,000 figure is too low? So this problem is about quantitative data. We have numerical information here. Compare that to the last section, which was always about categorical data. So when we define the parameter, instead of saying that P equals some number, we're not talking about a proportion here. We're talking about an average. So we're going to say let mu equal the true mean salary of graduates in the actuarial field. Same thing with the hypotheses. It's not P equals some percentage, it's mu equals some mean. So we're hypothesizing that this mean 1,000, and the alternative hypothesis is what this college placement officer feels, which is that's too low. In other words, it's above 40,000. Critical value is found the same way. We have a 5% alpha. It's a right-tailed test. All 5% of that is going to go on the right side of the test there. Right tail of the test. Look up 95%, which is going to be the area to the left of that, and we get our critical value 1.645. Standard deviation changes because we don't have a P anymore, so we can't do radical P Q over N. So instead what we're going to do is sigma over radical N. Okay? We know the standard deviation of the population. That's why we can use a z-score. That's why we know what sigma is. The next section is when we don't know the standard deviation of the population. We only know the standard deviation of the sample, and that's when we'll have to use a t-score instead of a z-score. For now, everything in this chapter, in this section, is about sigma. Part E, what's the test statistic? Test statistic, the z-score, and what we have at this point is a normal model. It's centered at that null hypothesis value. We believe that $40,000 is that actual average, and we're going to continue to believe it until we get to the end of our test and we see a p-value that's too low, and we go back and we reject that null hypothesis. So we're going to put that 40,000 right in the center. We just found a standard deviation of 500. Would it be unusual to take a sample of 36 graduates and see that they average 41,000? So we want to find a z-score for 41,000 or more to the right of that. Okay, we get a z-score of 2.0. We look that up in the table. Remember, the table is always telling us what's the area to the left of this, so we have to do 1 minus what the table says. P-value is 0.0228. So at this point, we can reject the null hypothesis because that p-value is smaller than the alpha level of 5%, and write our conclusion. Remember, this is always about that alternative hypothesis. So we rejected the null hypothesis, which means we have enough evidence to suggest that this is true. There's sufficient evidence to suggest that the mean salary of graduates in the actuarial field is above $40,000. Example 2 states that the average monthly rent for a one-bedroom apartment in San Francisco is $1,229. A random sample of 15 one-bedroom homes 15 miles outside of San Fran has a mean of $1,350. Is this evidence that the mean in this area differs from that of the city? The parameter, let mu represent the true mean monthly rent for a one-bedroom home outside of San Francisco. Hypotheses, mu equals $1,229, and the alternative is asking, is it different from that? So mu is not equal to $1,229. Critical value is a little different for this one because this time we have a two-tailed test. Our alternative is that mu is not equal to 1229, which means we're going to take this alpha and we're going to split it into two parts. Okay, we have area on the left side and the right side. So this 5% is going to get cut in half. 2.5% goes on this side. 2.5% goes on the left side. So together there's 5%, but it's split up. So when we look this up in the table, we can pick one. It doesn't matter which one. I'm going to pick the positive one. Okay, we move to the left of that, and we would look up 0.975. Okay, if we pick the negative one, we're just going to move to the left of this one, 0.025. When we look up either of these, we're going to get two numbers since there's a positive and a negative, positive and negative 1.96. Standard deviation, again, we're doing sigma over radical n. We know the standard deviation of the population. It says it right here. So 250 over the square root of 15, 64.55. Test statistic, again, we're assuming this null hypothesis is true. So to start, we're going to believe that the mean monthly rent in this area is also $1,229. If that's the case, would it be unusual to see this average based on a sample of 15 homes? Okay, now when we do this, we're going to get a z-score. We get a z-score of 1.87. So we want to find the area of this tail. Okay, so we would look up 1.87 in the table. Remember that gives us area to the left of that, so we have to do 1 minus. But keep in mind, since this is a two-tailed test, whatever we get for this area, we're going to mirror on the other side. Okay, so on this side, we get 0.0307, and there's another 0.0307 on this side. Okay, together, these two tails combine to give us our p-value 0.0614. At this point, we can make the decision to fail to reject the null hypothesis because the p-value is just above that alpha level of 0.05. For us to reject the null hypothesis, we need it to be smaller than that alpha level. When we fail to reject, we always say there's insufficient evidence to suggest that this alternative hypothesis is true. Okay, so we can't reject that this is true. The mean in this area might actually be 1229. If we took a larger sample, maybe we would get some homes that aren't as nice as the ones that we got in this sample of 15, and we'd find that the average is actually the same as San Francisco. There's insufficient evidence to suggest that the mean monthly rent for a one-bedroom house outside of San Fran is not $1,229. Lastly, let's do one with the traditional method where we cut out the p-value. Here we have a football coach who claims that the average weight of all opposing team's members is 225 pounds. We have a sample of 50 players taken from all the opposing teams, and the average of their weights is 230 pounds. Parameter, mu equals the true mean weight of all the opposing team's members. Hypotheses, mu equals 225. Alternative comes from the text of the problem. It's saying, is there evidence that the true mean weight is not 225? In other words, is it different from 225, not equal to for alternative hypothesis? Standard deviation, we know the standard deviation of the population. Okay, it tells us that it's 15 pounds. So sigma over radical n gives us 2.12. Test statistic, 230, this is our sample result of the 50 people that we chose. Subtract that mean value that we believe is the average weight of all players. Okay, we get a z-score of 2.38. Now, is that unusual using the traditional method? When we use the traditional method, we don't find a p-value, but we do find a critical value for this alpha. Just like the last problem, this is a two-tailed test. Okay, the alternative hypothesis was not equal to 225. So we're going to take this alpha and we're going to split it up and put half of it on each side of our normal distribution here. So half of 0.01 is 0.005. Put the other 0.05 over here. If we added both of those right and left tails together, it would total that 1%. We can look up either of these in the table. So if we look up this one, okay, we're going to get a z-score of negative 2.575. If we looked up this one, okay, and looked up 0.995, we would get the positive one. So there's just a plus minus in front of whatever we get. All right, sketch the curve and label it. So we have 0 right in the middle. We're talking about z-scores right now. Okay, these are our critical values, 2.575. Anything larger than that means our p-value is going to end up as something smaller than that alpha level. Okay, anything smaller than negative 2.575, same thing. We found the test statistic already, and we got 2.38. If we were to put this on our curve, it's not quite in that shaded region. It's in between 0 and that shaded region. And because of that, we can fail to reject the null hypothesis since the test statistic falls outside the shaded region. We're unable to reject this null hypothesis, which means we don't have enough evidence to say that that alternative is true. there's insufficient evidence to suggest that the mean weight of all the opposing team's members is not 225 pounds.